welcome back to another video. So today we will be discussing the midpoint line derivation algorithm. It's a very popular algorithm used in computer graphics, and we will be taking a look in details at how it works today. Okay, so take a look at the figure here on the left. This basically represents our computer screen. So our computer screen is made up of millions and millions of tiny pixels, and I've represented these pixels here in the form of these yellow circles. Alright, so every yellow dot here is a single pixel on the computer screen. Now, the rule for representing a graphic on a computer screen is that every single point on the graphic has to lie on a single pixel. Okay, so what I'm basically trying to say is that if my line starts from here, the next point that it can go to has to be this yellow dot here, or here, or here. So, and the next point it can go to has to be, on a yellow dot. Now, the problem is that in many cases, our lines or the circles that we draw, they don't always, lie on the pixels. So, for example, take a look at this red line. So it starts here at a pixel, and then when we move one unit to the right, it does not, connect to a pixel. It actually lies between two of the pixels here. And if we move again one step to the right, it lies again between two yellow pixels. So that is the problem that we're facing. And as programmers, we have to solve it by teaching the computer which pixel it should choose. So our line basically lies in the middle of two pixels. We can choose either this one or this one. And the midpoint line derivation algorithm is designed to help the computer choose the next pixel. I've listed 7 steps. So these are the 7 steps that I'm going to be describing in this tutorial. So let's get started. Okay, so our first step in understanding the midpoint line derivation algorithm is some basic assumptions. So we're going to have to assume that the line which we're going to be working with has to have two specific endpoints. So let's consider this red line here. It starts from the first point, x0, y0, and it ends at this pixel here, x1, y1. So it has a specific starting point pixel, and it has a specific ending point pixel. Right, so that's our first assumption done. Next, we have to make sure that our starting coordinate x0 is less than the ending coordinate x1. So x0, as you can see here, is less than x1. So our second assumption is met. And finally, so in the tutorial that I've made today, we are going to be moving in the x direction in every single graph. So what that basically means is we start here and we're going to move one unit to the right. So we will be working with these two pixels. Next, we will increment x by 1 again, and we will be working with these two pixels. So that's what it basically means. The value of x is going to increase by 1 each time, since we have chosen the x direction to work with. Alright, so that's assumptions done. Next, let's discuss the theory of midpoints. Okay, so what this basically means is if the midpoint that we have between two pixels is above our line, we are going to choose E. So what is E? Our starting point is x0, y0, and we have a compass here. So E is basically east, and to the east of our starting point, we have this pixel, right? And if we take a look to the northeast of our starting point, we have another pixel. So that's why we've called this one NE for northeast, and we've called this one E for east. And between these two pixels, we have our midpoint, and I represented that in green. Okay, so according to the theory of midpoints, if the midpoint M is above the line, so if we consider our line to be the black one here, then M is above the line. then we are going to choose E. Alright, so why are we choosing E again? Because as I've said before, our line cannot pass through the middle of pixels. It always has to choose a specific pixel. And we have to either choose, E or any, because our line is lying between these 2 points. And for the black line here, since our midpoint is above the line, we are going to be choosing the pixel E. Okay, so that's the rule. Alright then, so let's consider our red line here. In this case, our midpoint is below the line. So if the midpoint is below the line, what we do is we choose the pixel any. Okay, so very simple concept. Depending on the position of the midpoint, we choose which pixel we're going to, proceed with. So that was the theory of midpoints. And that is actually, the theory behind this midpoint algorithm. Okay, so next we're going to be taking a look at some of the common characteristics of a line, starting with the equation of a line. So f(x) of y. So what this basically means is a function with coordinates x and y can be represented by the equation ax plus by plus c. Okay, so this is the general equation of a line. And the general equation of a line can also be written as y is equal to mx plus b. So here m is the gradient and b is the y-intercept. So m is the gradient, and what does gradient mean? Gradient is basically the change in the value of the y-coordinate divided by the change in the value of the x-coordinate. So our y-coordinate becomes y1 and it used to be y0. So the change in the value dy is equal to y1 minus y0. So I've written that's the change in the value of the y-coordinate. So same for dx, it's the change in the value of the x-coordinate. And m is basically dy divided by dx. Okay, so I can substitute this m in our second equation, and I will get this here, y equal to dy by dx into x plus b. And if I simplify this further, I will get something like this. F of xy is equal to x dy minus y dx plus b dx. So if we compare this line with our first equation, we will get the coefficient of x was a, and here the coefficient of x is dy. So a will basically be equal to dy. The coefficient of y was b, and here it's minus dx. So b is equal to minus dx. And the coefficient of, so c has no coefficient. It will basically be equal to b multiplied by dx. Okay, so this was some simple, equations of a line. We should all already know this by now, but just in case. Okay, so now let's take a look at the properties of a line. So in this graph here, I have a line with the equation y is equal to x plus 1. So the purple line, okay? And I can also write this as fxy is equal to x minus y plus 1. I've just moved the y to the right here. Okay then, so for this equation fxy is equal to x minus y plus 1, if I consider a point on the line, for example the coordinate 0, 1, if I solve this equation for the point 0, 1, I will get 0 minus 1 plus 1, which is equal to 0. And that is our first property of a line. For any point that lies on the line, we will get fxy is equal to 0. In the same way, if I consider a point that lies above the line, for example 0, 2, and we substitute these coordinates in the equation again, we will get a negative number. So if a point lies above the line, we will get f of xy is less than 0. And finally, if we choose a point that lies below the line, for example 0, 0, we will get a positive value for f of x. So f 0, 0 is equal to 1, which is basically a positive value. Okay then, so these were our 3 properties of a line. Okay, so now what we're going to do is, you do remember our theory of midpoints, which we just discussed a few minutes before. We're going to relate this to the properties of a line. So according to our theory of midpoints, if if the midpoint lies above the line, then we choose E. Alright, so if our midpoint here, represented in green, lies above the line, for example the black line here, we choose the coordinate E. Oh, and why do we choose this coordinate E? Because the line is closer to this point, to this pixel, than it is to the pixel above it. Okay? And alright, and in the properties of a line, we've understood that if a point lies above the line, then fxy is less than 0. So just think of that again. So if a point lies above the line, fxy less than 0, and if m, which is also a point, lies above the line, then we choose E. So we can actually say that if fxy is less than 0, then we choose the point E. Take a minute to absorb that. If you didn't understand it, then, just read through it again. We've established that if fxy is less than 0, then a point will lie above the line. And we've established here that if a point lies above the line, we choose E. So yes, we can actually say this. If fxy is negative, then we choose the point E. In the same way, if our point lies below the line, we choose any. If the midpoint lies below the line, we choose any. And in this case, fxy is greater than 0. So basically, we can say that if fxy is greater than 0, then we will choose the point any. And remember, any represents northeast. Okay, so we've understood quite a few concepts here. Take some time to absorb this, and we will move on now to the next point. Okay, so till now we've understood two of our theorems, the midpoint theorem and some properties of a line. So let's go back to our graph here. Our starting point, we can represent that by a coordinate, for example, xk, yk. So you can choose any coordinate for that. You can also choose xl, yl, doesn't matter. So I've chosen xk, yk. Okay, and the line as it moves on, we are given two options. One is E, which is to the east of the starting point, and one is any, which is to the northeast of the starting point. So the coordinate of E is equal to xk plus 1 and yk. Why? Because E is actually 1 unit to the right of the starting point, and it's in the same position as the the y coordinate of the starting point. So I've written here plus 1 here, xk plus 1, and yk, the y coordinate, stays the same. In the same way, for any, we move one coordinate to the right and one coordinate above. So xk will increase by 1 and yk will also increase by 1. So that is the coordinate of our point any. And between E and any, we have a midpoint, which is basically xk plus 1 and yk plus half. So you can understand here, because we've only moved half a unit upwards. Okay then, so we've understood E, any, m, and our starting point. Now, do you remember this one? fxy is equal to x dy minus y dx plus bx. So in our line equations, we derived this, this formula. When I mention d, I basically mean the midpoint here. So let d is equal to this. So if d lies above the line here, we know that d is negative, and we choose the point E. And if d lies below the line, for example, this green point lies below the red line, we choose any. So after we've done all of this, we've chosen E or we've chosen any, what do we have to do next? Whatever we choose, if we choose E, we then have to move on to the next set of points. And after we've chosen a pixel here, we move on to the next set of points, which is, this one or this one. Okay? So after we choose E or any, we have to move on to the next set of pixels, and we have to choose another pixel. And in order to do this, we need to calculate the midpoint. So how do we calculate the midpoint? That is our question. Alright then. So we can either choose E and we can also choose any. So let's consider that we have chosen E. And we've chosen E because we've considered the black line. D lies above the line, that's why we've chosen E. And if we choose E, E will become our new starting point. And the new midpoint will basically be xk plus 2, yk plus half. And why is that? Because if E is our starting point, then our next two pixels are these. And the midpoint is represented by this pink dot here, which is basically xk plus 2, which means 2 units from our first starting point and half a unit up from our first starting point. Okay, so we have chosen E, and the midpoint now will become this pink dot here. And this pink dot's coordinates is xk plus 2 and yk plus half, because it's 2 units to the right and half a unit up. And we'll call that d new. So since fxy is ax plus by plus c, our equation of a line, we can also expand this by putting axk plus 2 in the place of x and yk plus half in the place of y, and we will get something like this equation here. So basically our new midpoint will be this equation here. Okay, so this is basically the same as this, we've just expanded it in the form of our line. Now our old midpoint used to be this one, xk plus 1 yk plus half, this green point here. We can also expand this in the form ax plus by plus c, and we will get this here. So the change in d is d new minus d old, and after we perform this subtraction, we will get a single value, and this value will be a. Okay, so to recap, if we choose E as our new pixel, we will get a new midpoint represented by this pink dot here, and the amount of change in D, and remember D is this, the value of our midpoint, the amount of change in D will equal to A. So therefore our new value of midpoint will equal to the old value plus A. Okay, so the entire point of all of this was, getting a new value for the midpoint, and we've derived that the new value is equal to the old value plus A. And we'll understand what A is later. So for now you've understood until this much. Now we will move on. So let's go to page 5. Okay then, so in the previous slide we considered choosing E. So now let's choose any. It's the same thing, the exact same thing. If we choose any, then our new midpoint will be between these two pixels. Okay, so if we choose any, then M is basically below our line. That's why we've chosen it. And then we get to choose between this pixel here, there we go, and we get to choose between this pixel here. And the midpoint between these two pixels is represented here. Okay, and that's its coordinate is given by xk plus 2 and yk plus 3 by 2, which basically means k plus 1.5. Okay, so our new midpoint is here if we consider any as our pixel. So again, we know that fxy is equal to ax plus by plus c. We expand it in that form. We get d new as this here. And we've just done this before with E. Our old midpoint can be written as here. And we calculate the difference between d new and d old. And we get this as a plus b. Okay, so I'm not showing you how the calculation has been done. I've written it all down for you. It's up to you to, perform these calculations by yourself again, and it will become much clearer that way. Alright then, so basically, okay, if we choose, this should be any. Alright, if we choose NE, then our change in D will basically be equal to A plus B. So D new, the new value of D will be equal to D old plus A plus B. I hope that you've all understood up till this point. If not, go back a few steps and re-listen to the video. There's a quick recap here of what we've been trying to do. We're trying to choose the best pixel using the position of midpoints because our line can't be between two pixels. And we've considered our first midpoint M as xk plus 1, yk plus half. And depending on the position of M, if it's above the line or below the line, we choose our next pixel, either E or NE. And depending on what we chose, E or NE, we can calculate the value of D for our next midpoint, which is either this one or this one. Alright, and we keep doing that for every consecutive set of pixels. So we'll calculate it for this and this. Actually, we don't do it, our algorithm does it. Okay then, so till now we've learned up to this much, and we're almost done actually. We don't have much left. Save that. Okay, so we've represented our, the value of D if we choose E. We've represented our value of NE if we choose, our value of D new if we choose NE. So let's do the same thing for our old value of midpoint. So our first midpoint was basically this, represented by the green dot. It was xk plus 1 and yk plus half. We can also write it in this form, the D form, D new, D old form. So we can expand it using our formula of a line, ax plus bx plus c. And after expanding, we get this equation here. And this part up to C can be represented by fxk and yk. Fxk, yk, okay, I should write this down. F x k and f y k. So let's put that y k. Okay, so fxkyk is basically equal to 0. Equal to 0. Because points on the line are always equal to 0. Okay, so fxkyk is equal to 0 because it's a point on the line, and we've already established that any point on the line will result in a value of 0 for this. So we can replace that with 0, and finally we get a plus b by 2. So d old is basically a plus b by 2. And then we get three equations, one for d old, 1 and 2 for d new, depending on what we chose, if we chose E or if we chose NE. Now, if you go back a few slides, and if you remember our equations of a line, we could represent A by dy, we could represent B by minus dx, and we could represent C by b dx by comparing it to ax plus bx plus c. So what I've done here is basically I've replaced the values of a, b with these values here. And finally, we get these three equations. D new for like this, for E. For NE, you get it like this, and D old like this. Alright then, so we've understood all of the concepts till now. Or the only thing that's left remaining is to understand the algorithm itself. So let's get started with that. Okay, so we are almost at the end now. In the last slide, we found out these three equations for D new, one for E, one for NE, and D old. Alright then, so we can write them in another way because you can see that there is a dx by 2 here, which means there is a fraction here. in order to remove this fraction, we can multiply all three equations by 2, and this will not affect our results because we only need, the sign of d. We just need to see whether it's negative and whether it's positive. Okay, so multiplying them by 2 will have no, effect at all. We can simply remove them. Alright then, so by multiplying them by 2, we get these three new equations, one for d new, two for d new, and one for d old. And as you can see, we've removed our fraction portion here. Okay then, so this is our algorithm, as we can see. So take a quick look at it, and I will be explaining it line by line. Okay, so I will be explaining it line by line, and we'll all see what happens. Okay, so in the first line, we've taken 4 numbers, 4 digits as input, and this is basically x0, y0, our starting point. And our ending point, which is x1, y1. Okay, so we've taken these 4 integers as input because this is our starting point and this is our ending point. Next, we've declared, let's see, we've declared 7 variables, and in the following lines, we'll understand what each is. So dx is basically the change in x. We've already, gone through this. It's x1 minus x0. dy is basically the change in y. And d is equal to 2 into dy minus dx. So if we go back to our 3 equations, we'll see that d is basically our initial midpoint, the value of our initial midpoint. So d is equal to the value of our initial midpoint. Okay then, so we can see something called INCR with a capital E. So that's basically increment of E. So change in E. So increment E, which means increase E by. So we're going to be increasing E by 2 into dy. Why are we going to do that? Because here, as we can see, in our equation for E, we have to add 2 into dy with our old value of, midpoint. So that's why our increment of E is equal to 2 into dy, because that is exactly the change. And the same thing we've done for any. As we can see here, the value that we have to add to our old midpoint d is 2 dy minus 2 dx. Therefore, increment of any, which basically means increase any by, is equal to 2 into dy minus dx. Right then, so we're done with a few of our variables, and we still have x and y left. So what they've basically done is x is equal to x0, which is our starting x coordinate, and y is equal to y0. So x is equal to our starting x coordinate, y is equal to our starting y coordinate. Okay then, and then we can see a function called right pixel x y value. So this is basically setting our first pixel as the starting point. So x, so how should I write this? Therefore, x0, y0 is our starting point. Okay? So that is what this right pixel line has done. In the next line, we can see a while loop. If x is less than, or while x is less than x1, this portion will be looped. So while x is less than x1, remember that this is our assumption. This is assumption number 3, that this algorithm is only valid as long as the starting point x is less than the finishing point x1. So if D is less than or equal to 0, we choose E. Okay then, so remember we've discussed all of this. I'm not going to repeat it again. So if D is less than or equal to 0, which means our midpoint is basically above our line. If our midpoint is above the line and thus D is negative, which means fxy is negative, we are going to choose E as the next pixel. And then if we choose E, then our d new is going to be 2 into d old plus 2 dy. Okay, so 2 dy has been stored in the increment of E, and they haven't written the value of 2 here because remember, as I told you before, multiplying something by 2 in this case, it has no effect at all because we need the sign mainly. So we can choose to leave out the 2 here, it doesn't matter. So leaving out the 2 is okay. Alright, next we've incremented our x by x equal to x plus 1. Why have we done that? Okay, if you just go back and scroll back to our graph, you'll see that if we go to E, then our x increases by 1 and our y coordinate remains the same, which is why they've increased the value of x by 1 and they haven't changed the y value. Alright then, so okay, we've done up to here and else. So if d is not less than or equal to 0, that means if d is greater than 0, what we do is we increase its value by this 2 dy minus 2 dx, which is our increment of any, and then we increase the value of x by 1 and we increase the value of y by 1. So we know why we've done this. X is y plus 1 and y equal to y plus 1. I should just note that this is, this isn't creating value for new midpoint D. Okay then, so we've done up to here, we've understood the entirety of our algorithm, and finally what we do is we do this here, right pixel, which means choose new pixel according to new values, x, y values. Alright then, so we're done with today's video, and thank you all for listening. I hope you've understood. If you have any questions, just please leave a comment below. Thank you so much.